In this particular example, we're looking to solve this equation here where we have a sine squared x and cos x. And in the example previous to this, we discussed, or I told you, that an approach when we have two different trig functions in the same equation is to try to factor to separate out the different trig functions to solve. Looking at this equation, we're not able to do anything with factoring here. We can't factor this. There's sine squared here, but there's no sine here. There's cos here, no cos here. So we can't factor this. So no surprise here, because if you look right above, there's the hint of how we're going to do this. We're going to use a trig identity to substitute in for one of our trig values. So if we take a look at this, we have a sine squared. So we know that sine squared of theta plus cos squared of theta is equal to 1. We should know that Pythagorean theorem by now. If you don't know it, don't break my heart and tell me that you don't know it. So to solve for sine squared, since that's what we want to substitute for, let's subtract cosine squared from both sides to get the statement that sine squared theta is equal to 1 minus cosine squared theta. Some pretty straightforward algebra to get sine squared by itself, sine squared theta by itself. Now we can go and substitute into our original equation here. So we had 2, and now instead of sine squared, we're going to put this information here. So let me do this. Put this in parentheses, and then in the parentheses, this 1 minus cosine squared in lieu of our sine squared. And then, so these, that comes from there. And then we have minus 3, and now we have cosine. Oops, I just realized I changed everything from x to theta. Okay, that's okay. We'll just stick with theta. Equals 0. So we substituted in for sine squared theta, and now we have our equation, and we can see it's all in terms of cosine theta. So now we just do the algebra. Let's distribute here. So we have 2 times 1, we have 2, minus 2 cosine squared theta, minus 3 cosine theta is equal to 0. I'm going to put this in the form, since we can see we have a quadratic. I'm going to put it in the form of decreasing exponents with this minus 2 cosine squared theta first, then minus 3 cosine theta, plus 2 is equal to 0. So I just rearranged the equation here in order of decreasing exponents to get it in a factorable form. And I don't know about you, but I personally, when it comes time to factoring, I don't like to factor when the leading coefficient here is negative. It just messes with my head in terms of how to be able to factor it. So what I'm going to do is I want to change that to positive. So I'm going to multiply each term by -1 on both sides so that I flip the sign of this first term. So now -1 times -2, so now I have 2 cosine squared theta, and I just wanted to flip this one, but the algebra requires that everybody gets its sign flipped. So now this is going to be 3 cosine theta, and this will be minus 2 equals 0. So now I have the equation in a form that we can factor it. Pretty straightforward. So I'm not going to do a U substitution here. Let me come up here to factor it. I'm just going to factor it from this. So I'm going to have 2 cosine theta minus 1 times cosine theta plus 2 is equal to 0. So factor this, and it factors like that. If you want to do the U substitution to help you factoring, by all means, go ahead and do that. I've skipped that for this video. Now, as we know, each of these becomes its own equation. So 2 cosine theta minus 1 equals 0, and then cosine theta plus 2 equals 0. So let me make my line there so we can follow what we're supposed to do here. Solving this first equation, let's add 1 to both sides of the equation. So 2 cosine theta is equal to 1. And then last but not least, we divide both sides by 2 to get cosine theta is equal to 1/2. And this is positive. So the equation is cosine theta is equal to 1/2. And now the question is, what angles have a cosine of 1/2? Well, we know that we're going to have one answer from Q1. And for cosine, our other answer is going to be from Q4. In Q1, the angle that has a cosine of 1/2 is pi over 3, or 60 degrees. And then in Q4, that angle is going to be 5 pi over 3. So we have two answers so far from this first equation, from this first factor. Now let's take a look over here. Algebra, to solve this, subtract 2 from both sides. Cosine of theta is equal to -2. Now the question is, what angle has a cosine of -2? And there is no such angle. So there's no solution or the empty set. When we look here, we're looking at the cosine of theta. There is no change in the amplitude, so amplitude is 1, which says that all our trig functions, trig values for cosine have to be in between -1 and 1 inclusive. -2 is not in that interval, so there is no such angle. So we end up having just the two solutions from this first factor.